Your variable names might be perfect, but if your functions are bad, your code is still hard to read. Welcome to TechCraft Mentors. Today, we continue our journey from code that merely works to code that is clean and meaningful. In the previous video, we focused on naming variables and how good names make code readable without explanations. We talked about naming variables, and now we move one level higher to functions where clean code decisions have an even bigger impact. Functions matter because they define behavior. This is where most bugs, complexity, and duplication are introduced. Functions are the primary way we communicate behavior. If functions are messy, the entire code base becomes hard to understand, no matter how correct the logic is. Broadly, we can classify functions based on what they do. Command functions perform an action, while query functions retrieve data and return it. In many code bases, we often see functions that both retrieve data and perform an action. At first, this works fine, but as the application grows, these functions become difficult to maintain because they're doing two different jobs. Any change in the data being retrieved or the action being performed forces us to modify the same function. And because of that, the function can't be reused for a single purpose. It's tied to both, whether we need them or not. Just like variables, functions also benefit from meaningful, self-explanatory names. A good function name clearly describes the action it performs. Let's look at a few simple naming guidelines specifically for command functions. Rule number 1, use action-oriented words because command functions perform actions. The name should clearly describe the full activity being performed, so no one has to read the function body to understand what it does. If the purpose isn't obvious from the name itself, the function is already failing its first responsibility. For example, command function names like apply seasonal discount, calculate total invoice amount, and mark order as shipped make the intent immediately clear. Just by reading the name, you know exactly what action the function performs. No need to open the code. When naming variables, we stress the importance of using domain words. The same idea applies to functions, but here, we use domain activities. Function names should describe the business process they represent, not the technical steps used to implement it. Let's look at a few examples to see the difference. Apply seasonal discount is much more specific than apply discount. It tells us the exact business process involved. The same idea applies to names like calculate total invoice amount and mark order as shipped. Each one describes a clear business action, not a vague technical operation. Now let's look at a few simple naming guidelines specifically for query functions. Rule number 1, since query functions retrieve data and return it, their name should reflect that behavior. A simple and effective convention is to start these functions with words like get or load. Rule number 2, after using get or load, the name should clearly state what information the function retrieves and returns. This way, the return value is obvious just by reading the function name. Rule number 3, if the data is retrieved using specific filter criteria, including the criteria in the function name makes it even more meaningful. This way, the function name tells you not just what data is returned, but also under what condition. Let's look at a couple of examples that follow all these rules. The function name getUserById immediately tells us three things. It's a query function. It returns a user, and the data is fetched using an ID. Now the function name getActiveCustomers. Again, the get prefix tells us it's a query. The plural customers tells us it returns multiple records, and active clearly states the filter being applied. Query functions are not limited to fetching data records. They can also be used to check a status, determine an ability, or perform validations, while still returning information. Functions that answer these kinds of questions are usually named with prefixes like is, can, has, or should. Just by reading the name, you know the function will return a yes or no answer. When naming these functions, include the type of check being performed, whether it's a status, ability, or validation. This makes it clear what the function is evaluating, not just that it returns true or false. Let's look at a few examples of these query-style function names. Is valid mail address, performs a validation check on an email address. Has sufficient balance, checks the current status of the balance. Is order eligible for discount, determines whether an order has the ability to receive a discount. Should send reminder email, checks whether an action should be performed. And can user access resource, evaluates whether the user has the ability to access a resource. Now that we understand how to name functions, let's move on to the principles and practices that make their implementation readable and maintainable. Fail fast is a practice that helps us avoid deep nesting of if statements. Instead of checking a condition and writing logic inside it, we reverse the condition and return immediately when the rule is violated. This keeps the function flat, readable, and easy to reason about. Let's understand this with a code example. In this example, we have 3 separate conditions, checking whether account ID, ACC, and new credit limit are not null. Only when all 3 conditions are satisfied do we execute the actual business logic. This creates nested if blocks, which makes the code harder to read and reason about. And as nesting increases, even simple mistakes, like a missing closing brace, become difficult to spot. Now we apply the fail fast rule to the same code. In the after version, notice how the nesting disappears. The conditions are handled up front with negating the condition, and the core logic becomes easy to read, maintain, and reason about. One of the most important principles in clean code is the single responsibility principle. It says that a function should have one clear responsibility, and if you need to explain what it does, it's probably doing too much. A well-designed function does one thing, does it well, and does only that. Because of this, there is always just one reason for the function to change. In this code example, the function update opportunity amount is doing more than one job. It updates the opportunity record, it updates the account record, and it also decides which discount should be applied. Because these responsibilities are mixed together, the function violates the single responsibility principle. Any change in opportunity updates, account updates, or discount rules would force us to modify the same function. After applying the single responsibility principle, the original function is split into 3 smaller functions, each responsible for a single task. Now, each function does one thing and has exactly one reason to change. A change in one behavior no longer impacts the others, making the code easier to maintain and safer to modify. A function should operate at a single level of abstraction. It shouldn't mix high-level business intent with low-level implementation details. When abstraction levels are mixed, the function becomes harder to read and reason about. Do not worry if the explanation doesn't make sense to you. Let's try to understand it using simple day-to-day life analogy. Here we see the senior manager, and workers. We see the interaction at only one level. Senior manager assigns task to manager. A manager's responsibility is to ensure the task gets done, not to do the work personally. So the manager breaks the work into smaller tasks and assigns them to the right people. If a manager starts managing the process and doing the actual work, it creates confusion and conflict. Responsibilities overlap, focus is lost, and the system stops scaling. Each worker focuses only on the subtask assigned to them. Nothing more, nothing less. Workers don't assign tasks to each other. They simply do the work they're given. Now let's see how this idea translates into code. At the top, the senior manager function calls the manager function update opportunity and account amount. That manager function coordinates the work by calling get percentage to be applied, update opportunity amount, and update account amount. Each of these lower-level functions focuses on exactly one task and nothing else. A class or function with a lot of code is often called as God class or God function, and it is not a clean coding practice. If a function doesn't fit on one screen, it's usually a sign that it's doing too much. Needing to scroll up and down just to understand a function breaks the reader's flow. There's no strict rule on function size, but when you follow the single responsibility principle, small functions come naturally. Function arguments should be kept to a minimum, ideally 0 to 2. As the number of parameters grows, clarity drops very quickly. If a function needs many inputs, group them into a class, and pass a single object instead. Boolean parameters are a major red flag. They usually hide multiple behaviors inside one function. For example, calling getUserById true tells us nothing about what true actually means. When a value doesn't explain itself, the function needs to be split or renamed. Developers often end up implementing the same functionality in multiple places, which leads to duplication. This happens most often with so-called utility functions. Placing such functionality in a single, well-defined location makes it easy to find, reuse, and maintain, without recreating it everywhere. To write maintainable code, there's another principle which says encapsulate what varies. It means write a separate function for the things which can change and call that function where that value is needed. Some of the things which often changes are formatting, calculations, and conditions. This code snippet demonstrates the encapsulate what varies principle. In the before version, the condition is written directly inside the if statement. After applying the principle, that condition is moved into a separate function called canUserLogin. This gives us two clear benefits. First, if the login condition ever changes, we update it in one place only. Second, the calling code becomes far more readable and almost English-like. Instead of reading complex logic, we read intent. If canUserLogin, then allow login. When we look at a condition written directly inside an if statement, all we see are variables and operators. It's hard to immediately understand what that condition is actually checking. Instead, we can make the condition self-explanatory by assigning it to a meaningful variable name. In the before code, the condition is embedded directly in the if statement, so the intent is hidden. In the after code, the same condition is stored in a variable called isNetIncome and income tax slab. Now, when this variable is used inside the if statement, the condition reads clearly and instantly makes sense to the reader, without having to decode the logic. We've covered several clean coding principles and practices. Each one may look small on its own, but together they deliver enormous benefits. Clean code is rarely about big, dramatic changes. It's about making small, thoughtful improvements again and again. And over time, those small changes create a big impact.